This video is a walkthrough tutorial for part 3 of the hurricane exercise for GPH301, Intro to Quantitative Geography. Up to this point, we've been working with hurricane, or rather tropical cyclone data, looking at frequencies of the occurrences of different types and levels of storms, and then looking at how we can characterize that frequency both in terms of statistics, but also in terms of graphing them, looking at both the trend line and also the confidence interval around that trend line, to get a better sense of how well the data is characterizing what's going on. From this point forward, we'll be working with a separate workbook to look at specifically damages and deaths from hurricanes and understanding how we can characterize those events. So looking in Canvas in Hurricane Exercise Part 3, you'll see the link to both the PDF document that describes the exercise as well as the workbook, which in this case is called Hurricane D&D, and then S20 for Spring 20. This tutorial is going to be working with Microsoft Excel application on a computer, so it presumes that you have access to that. If you don't have access to that, you'll need to use the Microsoft Excel Online Web Edition, which all students have access to. If you need to use that, I'll be doing that in a separate video, and I'll put a link to that on Canvas. All right, today we're going to be looking at the Part 3 of Hurricane Exercise. So I'm going to open up the PDF document first just to remind you that all the exercises that we're doing in the class are described in detail in this PDF document. So this includes not just the description of the general assignment, but also the walkthrough about what you would need to do. So in theory, you could follow this and catch up with the class or even get ahead if you wanted to. It's a little harder, I recognize, to follow step-by-step instructions through reading, but it's there nonetheless, so it walks you through what you should expect to do. So we're going to work with the data here from Hurricane Exercise Part 3, Hurricane D&D. So I'm going to open up that document in Excel so we can walk through it. So this exercise works with very similar data to what we've had before. So we have, as before, data over time, although this time we're going further back, starting with 1900 up to the present, up to 2019. We have the number of named storms each year, the number of hurricanes each year, the number of major hurricanes, the accumulated cyclone energy index, which we're not going to use, and now we have the number of deaths from tropical cyclones in that year. These are from North Atlantic cyclones. And then also new, we have damages, and the damages are described as being in the millions. And what's important to understand here is that that means that when you look at the number, for example, for 1900, it wasn't that there was $30 in damages, rather it was $30 million in damages, nominally. So what that means is that when you look at these numbers, you need to multiply them by 1,000,000 to get the real number for that time period. But the second thing that's important to recognize is the word nominal. So in this case, nominal means the price tag at the time. This is what people were charging then. So in 1900, there were a lot of deaths. There was a particularly bad hurricane that happened in Galveston, Texas, which killed a lot of people, and it leveled the entire town at the time. And it was estimated that it cost about $30 million in damages. Now, that doesn't mean that that's how much it really costs, because we know that the value of a dollar goes down over time. We call that inflation. Inflation referring rather to the cost of things, right? So it costs more to buy stuff. So if you had to rebuild the town today, given the damage that occurred then, it would probably cost a lot more. And so the question is, how do you adjust for that change over time in the value of a dollar, right? So this is a common problem when you want to compare money over time. So let's look at an example. If you look at the Movies Nom tab in your workbook, you'll see the price, or the average price of a movie ticket in the US across time. So you see it runs from 1948 up to 2017. And so you can look at the graph and you can look at the table, and you can see that in 1948, the average price of a movie ticket in the US was 36 cents, which sounds really, really cheap. But of course we know that money was worth more back then, right? Things were cheaper only in a nominal sense, right? Because it was also harder to come by money at that point in time. We see that over time, the nominal price of a movie ticket goes up. So we kind of know that intuitively, that things just cost more later in time. But the question is, how much more does it really cost, or has the actual or the real, and I'm putting the word real in quotes here, how has the real price of a movie ticket changed over time? So one way that the government does this to consider the changing value of money is to consider what's called the Consumer Price Index, and so, or the CPI. And this is an idea that in order to track the changing value of money, you look at what the money can buy. So imagine that you were buying a basket of goods from the supermarket, say milk and eggs and bread. And so you know how much that costs today. And so the question is, how much would it cost you to buy the same stuff in the past or in the future, right? So we're talking about the same things you're trying to purchase, but we know that the actual amount of currency you'll have to use will change over time. And so this is the distinction between the nominal value of something and the real value of something. So we can adjust for the real value by compensating for that change in the value of the currency by taking into account the inflation or the consumer price index. So if we look at the movie's real sheet, we can see two lines on this graph. The blue one is the original one we looked at, which is the nominal price of a movie ticket over time, right? And so we see the nominal prices of movie tickets actually change, not surprisingly. But the orange line shows us the real price. So this is taking into consideration what money can buy at a given time. And what we see is that movie tickets were cheaper compared to today back in 1948. So the real price of a movie ticket in 1948 was about $3.67, which is a lot cheaper than today. But notice that the real price of a movie ticket jumped pretty dramatically, so that by the early 1970s, the real price of a movie ticket was all the way up to $10, which means that in real dollars, movie tickets were actually more expensive in the early 70s than they are today. And in fact, if you look over time, you see that this line only drops a little bit, so that actually the price of a movie ticket today hasn't really changed much in the last almost 40 years. So that's kind of astounding when you think about it, because even though the nominal price tag of that movie ticket has gone up, in terms of what money can buy, the real price actually hasn't changed very much. And so it's this concept that we're working with that allows us to compare value over time to really see whether the value of something has changed. So the way that you can do this conversion to adjust for inflation is to use these conversion factors. So in the data conversion factors sheet on the bottom of your workbook here, you'll see this information, these tables, which comes from government calculations of the Consumer Price Index. And the way it works is relatively simple. So you'll see here in the first column 1774, which literally means the year 1774. And over here in this column, in the B column, you'll see the conversion factor. And what that means is that that value there is that over the period 1982 to 1984, which is what this is looking at here, 8 cents is the equivalent of what a dollar would be, or rather 8 cents in 1774 is the equivalent of what a dollar would be today, or in that time period. If we want to compare it closer to the current time, we're going to scroll across the screen, but because this screen is going to be really, really big, I want to freeze the panes of this worksheet so it's a little easier to maneuver and we don't get lost. So to do that, I'm going to go to the Windows or the View menu up top, and you'll see there's an option to freeze panes. So I'm going to drop that down and I'm going to choose to freeze panes. Now, when I do that, it's important where my cursor is located. So when I click that, the fact that my cursor was right here in this cell and in this one right here in B34 is important, because now if I scroll down, you'll see how this top part doesn't move, and if I scroll to the right, you'll see how that first column doesn't move. So it's real convenient. So, okay, the whole point of that is, so we want to find the data for today. So if we look back at 1774 and we scroll over to the more recent time, we can see that in 2017 right there. So we can see that 3 cents in 1774 is roughly equivalent to what a dollar can buy today. Right? That's how we understand that. So, but we're interested in looking at, for our data, is doing the conversion factor. So we're going to scroll down to where our data begins, which is in 1900. So in 1900, okay, we see right here, it's in cell Z160. We can see that roughly, it's not hasn't changed much. So about 3 cents in 1900 bought what a dollar could buy today, or in 2017 dollars. So we're going to use this conversion factor to convert our data. So what that means is that in our original data set here, we're going to add a column to calculate real dollars. So I'm going to add a column and I'm going to call it damage keeping the same units, millions, but I'm going to call it real 2017 dollars, which is kind of a mouthful. But that's what we're looking at, and I'm going to wrap that so it's a little more readable. There we go. All right. So in order to convert this $30 million in 1900 to 2017 dollars, I'm going to put a formula in here. I'm going to start with equal sign, take that 30 million, or that value, and divide it by that conversion factor. So I'm going to go back to this table here, looking for that 1900 for 2017, which is right here, Z160, okay? And you can see my formula bar up here, and I'll hit enter. And so this value is the value of that in 2017 dollars. So $30 million in 1900 is the equivalent of over $882 million in 2017 dollars. So you can see there's a really big change in the value of a dollar. So it costs a lot more money nominally to account for the same amount of damage. So we do that for all the rest of these numbers here, and so we're going to drop this down, copy this formula down all the way to the current era, and we can see back to down to 2019. You'll notice that when we start getting numbers that are in the thousands over here, remember that we're multiplying by a million. So now once we we cross into the thousands over here, 1,000 times a million makes a billion. So we're looking at billions of dollars of damage over here. It might be helpful in this case to convert these numbers into dollars, or rather into currency units. That might make it easier to remember what we're looking at here. So I'm going to highlight those cells, and I'm going to change the formatting of them by going to the home menu up top and then choosing the dollar symbol right there. And so what that'll do is you can see then that we're talking about money, right? The little dash there indicates a 0, so there was no damage that year. And again, keeping in mind that these have to be multiplied by a million to give you the true value of what you're looking at here.